3.7, we're going to deal with linear equations again. We're actually going to create our own now, though, instead of being given them like in the last section in 3.6. So as always, we'll start out with an example. It says alkanes are a type of molecule that only has hydrogen and carbon atoms that join together with single bonds. In a structural formula, these single bonds are shown by a line segment with C connecting with an H. The first straight chain alkanes are shown below in the following table, starting with methane, the smallest alkane. So just to kind of dissect what we mean for this, it basically just means that there's one carbon in the middle, and then at every 90 degrees there's a hydrogen coming out. So there's one carbon and 4 hydrogens. So if we look at the chemical formula, we see there's carbon, which is just 1, and there's 4 hydrogens, right? So if we wanted to write that as a pair, there's 1 carbon and 4 hydrogens. Okay? If we go to ethane, the next one down, we just add 1 carbon atom in the middle. So we have 2 of them, and it branches out into 6, right? Because there's 2, 2, and 2. So it's C2H6, and it goes 2, 6 for the ordered pair, right? So what about propane? Well, it looks like there is 3 carbons. So if I rewrite that as a chemical formula, it's C3, because there's 3 carbons. And it looks like I have 8 hydrogens. Okay. If I wanted to write that as an ordered pair, well, it's just 3, 8. Okay. What about butane? So if you've seen the pattern here, all we're doing is just adding 1 carbon each time. So this one's going to have 4 carbons, right? So I'm going to write 4 carbons, and they're just connected in a straight line. And then instead of writing all the H's, I'm just going to show the connections. So it looks like we always go 1 up and down, and then we have 2 on each side, or 1 on each side. Right? Okay. So how many connections are there to hydrogen atoms, or how many hydrogen atoms are there? It's the same question, right? So we have 8, 9, and 10. So it should be C4H10. Okay. If I wanted to write that as an ordered pair, it'd be 4, 10. And now instead of doing the rest, I'm going to omit these last 3. So you can do those on your own if you want. But I will give you the answers to all 6 of these boxes down here. So we've seen that every time we increase our X pair, or our number of carbon atoms, by 1, we increase the number of hydrogen atoms by 2, right? So we go from 1 to 2 here, we go from 4 to 6 here, 6 to 8, 8 to 10, right? So we increase by 1 on the left side every time, and we increase by 2 on the right side. So the next one should be 5, 12, then 6, 14, and finally 7, 16. Right, so then if we go backwards 1 step and we write their chemical formula, this is just the number of carbon atoms, this is the number of hydrogen. So we get C5H12, C6H14, and C7H16. 16. Okay. So if we kind of look at this, it says complete the following chemistry formula for the nth alkane by generalizing the pattern shown in the formula column, right? So I want to know if I have an n amount of carbon atoms, so I have n, so we don't know how many we have, it's just some variable, then how many hydrogen atoms do I have? Well, let's see. It looks like every time I get a new hydrogen, or a new carbon, I get 2 more hydrogen, right? So that's just like the slope here. We just add 2 every time. So if I wanted to write a formula for that, well, I know my slope is 2, right? So I'm going to say 2n is my slope, but then I want to know what my y-intercept is for this, right? So how can I find my y-intercept? Well, remember from the last section that our y-intercept, or I guess I'll label it b, our y-intercept is always some 0 for my x value, and then there's some y value, right? So is there anything on here that starts with a 0 for my x value? Well, I don't see anything, right? Because it goes up to 1. But we know that if we're adding 2 every time this way, we can go backwards 1 and subtract 2, right? So if I have 0 carbon atoms, then I would have 2 hydrogen atoms. So that's my y-intercept, right? So what I can do is 2n plus 2 down here. Right? So 2n plus 2 is the number of hydrogen atoms I have. And we can check to make sure this works. I'll plug in 3 here. So I plug in 3 for carbon. So n is 3. I plug in 3 over here. I have 2 times 3, which is 6, plus 2, which is 8. Right? So we verify that this is the right formula. Okay? So what if we want to write this as a function rather than something like this, like our chemical formula? Well, my number of hydrogen atoms is just 2 times the number of carbon atoms I have plus 2. So my slope is 2 and my y-intercept is also 2. Right? So my slope is just the number of hydrogen atoms I add every time. And my y-intercept is just the number of hydrogen atoms if I had a 0 carbon alkane. For a 0, so the number of hydrogen atoms for a 0 carbon molecule. Right? So I specifically say it's a 0 carbon molecule because if it doesn't have any carbons, it can't be an alkane, right? So it's kind of a hypothetical thing. Alright? Alright. So if I have a straight chain alkane with 10 carbon atoms, how many hydrogen atoms do I have? So I'm going to go back to that formula on the last page. So I have the number of hydrogen atoms equals 2 times the number of carbon atoms plus 2. Right? So if I have 10 carbon atoms, I just plug in 10 for C. How many hydrogen atoms do I have? So I have H equals 2 times 10 plus 2. Right? So that's just 22. So I have 22 hydrogen atoms. Okay? So what if I have a straight chain alkane with 10 hydrogen atoms? So how many carbon atoms do I have? Well, then I know that I have 10 hydrogen, and I have 2 times the number of carbon plus 2, but I don't know what the carbon is, right? So I can solve for that. So I can subtract by 2 on both sides first. So I'll have 2C equals 8, and then divide everything by 2. So C equals 4. Right? So the number of carbon atoms I need is 4. And if you want to check that, actually, we can verify that on the first page because we filled that out as an ordered pair already, right? Alright. And then my final question, is it possible to have a straight chain alkane with an odd number of hydrogen atoms? Why or why not? So if I look at this formula, the number of hydrogen atoms I have is 2 times the number of carbon atoms plus 2. Well, 2 times the number of carbon atoms, whatever those two are multiplied together, I'm going to end up with an even number, right? So 2 times 1 is 2, 2 times 2 is 4, and so on. So I'm always going to end up with an even number here. And I'm going to add to it 2, which is also an even number, right? So no matter what I do, I have an even number plus an even number, which is always going to be an even number. So it's not possible because I'm always going to get an even number on the right side. So the number of hydrogen atoms I have is always an even number. So it's not possible. Okay. Alright. So how we've been doing this is when we're writing an equation of a line, we're going to do it in slope-intercept form. So how we're going to do that is we're going to write it in this form, right, where m is our slope, b is our y-intercept. Somehow we're going to find the slope, and then we're going to use the slope to find the y-intercept. Okay? And I'll show you how to do that on the next page. So that's our basic formula, is we're going to first use this to find our slope, use the slope to find the y-intercept. And then we can just plug those two values into this, and we'll get our answer. Okay? So I know that was a little bit to take in, but let me show you what I mean. So this one, we're actually given a slope, and then we're given a point that it passes through. So this one is actually pretty easy, right? So this one's special, this point right here, because 0, -8 is our y-intercept, right? We have our x equals 0, and our y-intercept is -8. So this one's pretty easy. So y equals 4x minus 8. But what if we go a little bit harder? So maybe something like this. So this one we aren't given just our y-intercept, right? But we are given our slope. So if I write this, I can say y equals 4x plus b. Right? So we just plug in our slope. We don't know what our y-intercept is yet. But we do know a point, right? So what if we solve for this b, this y-intercept? Why don't we just plug in those two numbers into y and x? So I'm going to do that. So I have x is 1 and y is negative 8. 4 times 1 plus b. So I get negative 8 equals 4 plus b. And then now I can subtract 4 on both sides. So I get b equals a negative 12. Okay. So if I know b is negative 12, I can just plug that right back in to the formula that we started with. So I get y equals 4x minus 12. Okay. So that was pretty easy. But what if I'm given 2 points, but I'm not given my slope, like on the next one? Well, we know how to find the slope of 2 points already, right? We have this formula where it's m, or slope, is equal to y2 minus y1 over x2 minus x1. Right? So I can just plug in those values. So this is my second point, this is my first point. So this is equal to 4 minus 6 over negative 4 minus a negative 8. So what do I get? Well, 4 minus 6 is negative 2. Negative 4 plus 8 is positive 4. So that'll simplify to negative 1/2. Okay? So now I can plug that into a formula that we had up here, right? Just imagine that 4 is an m. So we have y equals negative 1/2 x plus b. And how can we find b? Well, let's just do what we did up here. Let's just plug in one of the 2 points. So I'm going to plug in the negative 4, 4. It doesn't matter, though, which one you plug in. You'll get the same answer. Right? So I'll have 4 equals a negative 1/2 x plus b. Sorry, and the x should be a negative 4. So negative 1/2 times negative 4 is a positive 2. Subtract 2 on both sides. We get b equals 2. Okay? So now I can plug that back in to the formula we have up here. So y equals a negative 1/2 x plus 2. Okay? Alright, so what if I have something like this? What if I have a table? Well, this one's pretty easy, right? So we know what our y-intercept is. It's 5, because we have 0, 5. If we look at these as ordered pairs. So I know b equals 5. And my slope is just how much I'm changing each time. So I'm changing by a negative 3 each time, right? So I'm subtracting 3 each time. So I know that my slope, m, is just equal to negative 3. So now that I know my slope and I know my y-intercept, I can just plug those into the slope-intercept form and get my answer. So we get y equals a negative 3x plus 5. Alright. Let's look at the next page. So this one says, write the equation of a horizontal line that passes through negative 3, 5. So I'm going to draw that here. So I'm going to have a point at negative 3, 5. So up here. Okay. And I'm saying it's a horizontal line. Right. So from a few sections ago, we know that a horizontal line has a slope of 0. So my m equals 0. And I want to know, for my b, for my slope-intercept form, where does it cross the y-axis? Well, if this is the horizontal line, we know that that's going to cross the y-axis at y equals 5, right? Because it's just a horizontal line. Right? So my b is 5. So I plug that into the formula, I get y equals 0 times x plus 5. Right? And what's 0 times x? Well, that's 0 plus 5 is 5. So my formula here for this horizontal line is just y equals 5. Right? Because we can plug in any point if we want to. So like if we have negative 5, 5, we plug in negative 5 for x. Well, there's no x, so that doesn't matter. plug in 5 for y, we get 5 equals 5. Okay. What if we have a vertical line here, though? So if we have a vertical line, so -3, 5, so it's going to go this way instead, right? So what is our slope here? Well, our slope is undefined, right? So what other information do we know about this? Well, it never crosses the y-axis either, right? So it's never going to have an answer for b. But we do know, if we kind of look at this one as an example, we know that x is always going to equal -3, right? So my equation for this one is actually going to be x is equal to a -3, right? And it's always going to be that, no matter what I plug in for my y value here. It's always going to be -3, 10, -3, 8, -3, -3, something like that. But it's always going to lie on that line. So x equals -3 is my answer there. Okay? So, whenever I'm looking for a vertical line, it's just x is equal to whatever my x value is. If I'm looking for a horizontal line, it's always y equals whatever my y value is. Okay? So if I asked you a question, write the equation of a horizontal line and a vertical line through the point 5, 8. Well, I know x is always going to equal 5 for my vertical line, and y is always going to equal 8 for my horizontal line. Okay? All right. So that one was pretty easy. So let's look at this last one here. So this last one says, two friends are running through a state park where a 10-mile path is labeled with mile markers. They are experienced runners and maintain a constant pace, or a consistent pace rather. So this is just alluding to the fact that we're going to have a linear equation because it's a consistent pace. Okay. So this one says John passes the mile marker 2 at 1:18 and a mile marker 5 at 1:45. So Mike started later than John and is trying to catch up. He passes mile marker 2 at 1:30 and passes mile marker 5 at 1:54. So write a linear function to describe each man's location d on a path which the mile marker as a function of t of time since 1 p.m. So the first thing I'm going to do is I'm going to look at John, and I see that he has these two times. So he has a mile and a time. So I'm going to write those two as ordered pairs. And we're looking at the time after 1, right? So this is 18 minutes past 1. This is 45 minutes past 1. So John, his two ordered pairs is 2, 18 and 5, 45, since there's 45 minutes after 1. Okay? And then Mike, his times, we have, 2, 30, and we also have 5, 54. So how can I find my linear equations? Well, I have 2 points, so I can find my slope, right? So my slope m is equal to y2, which is 45, minus y1, which is 18, over my y2 minus, or my x2 rather, minus my x1. So after you do that, when you subtract on both sides, you should get, I believe, 9. Yeah, so you should get 9 here after you do that. And similarly, we can do the same thing over here for Mike. So m equals 54 minus 30 over 5 minus 2. And you should get 8 for this one. And you can verify that on your own if you'd like. And then now we have our slopes. So we have y equals 9x plus b over here, and y equals 8x plus b over here. So basically what that's saying is he runs an 8-minute mile and he runs a 9-minute mile right now. Okay? So how can I find these b's? Well, I can just plug in either of these points, right? And I'm going to work with the smaller ones just so it's easier to work with numbers. So I'm going to plug in 2 and 18 into this. So 18 is my y value, 2 is my x value. So I have 18 equals 9 times 2 plus b. And then 9 times 2 is 18. Subtract 18 on both sides. We'll get 0 equals b. So I just multiply and subtract. And then over here, we'll plug in 2 and 30. So we get 30 equals 8 times 2 plus b. That'll be 16, so we'll subtract 16 on both sides. We'll get 14 equals b. Okay? So we plug in 0 for b here, we plug in 14 for b here. We get John's linear function is equal to, and I guess I'll write it, d is the distance that they run, equals 9 times t, the amount of time that they've spent on the path so far, plus 0, right? B equals 0. And then for Mike, we have b equals 14. So I'm going to say his distance, d, is equal to 8t plus the 14 that we found for b.